how do we factor? And as you're factoring, some of the things to remind yourselves about as you're going through to factor. Let's just do a couple of these. What I want to look at is 1 and 2 for right now. I guess I should let her back in. If you were taller, you could see over that. Tippy toes don't count. When you're factoring stuff, there are specific things that you're always going to look for first. What is the first, always, all-time rule of factoring? GCF. The first thing you want to do is look for that GCF. Okay? The second thing you would do is factor, I don't know, somehow, some way. Now, if you know the lyrics to the song, you're thinking it right now. Really? No? Hannah, you're smirking because I think you know it. You know it? Are you coming up with funky every single day?
Can we watch it?
No, you cannot. Oh well. Anywho, if I'm looking at these first two, what's the first thing you do for 4x squared and 24x?
4x.
Factor out the 4x. Good. So when you factor out the 4x, you're left with x minus 6. Is there anything else that you can do then? No. Now, just for argument's sake, what would you do then if it equaled 0?
Set each of them equal to 0.
Set each one equal to 0, and you already told me the zeros would be at
0.
0 and 6. Very good. Now, what direction is this graph going? What are the tails doing?
Going up.
They're both going up. All right. Now, on the second one, there isn't the GCF. And this is the one that a lot of you guys tend to not like. Now, what you have to do here is you have to multiply the first term and the last term together. I always set these things up by factoring by what we call grouping. Okay? Split middle term, you might hear it called. So what's 2 times negative 21?
Negative 42.
Okay. What are two things that you can multiply together that equal negative 42, but they add together to get 11?
6 and 11. Negative 6 and negative 5.
Let's try this again.
Negative 6 and negative 5 equal
Negative 2.
30.
You want to multiply to negative 42, but you want to add to 11. Wait, 6 and 5, yes, that equals 30. Yes, you were.
14 and negative 3.
14 and negative 3? 14 and negative 3. So when we factored these things by grouping, when I had one value that was positive and one value was negative, what was my little trick that I did here? Do you remember that? Which one would I write down first? You remember? Whenever you have two terms that one's positive and one negative, when you're going to factor by grouping, it's usually easier on your brains to put that negative one first. And the reason that I do that is when you group them out in pairs, you don't have to worry about factoring out a negative on the second term. It just looks a little bit cleaner. Does that make sense? Mm-hmm. Sometimes you can't avoid it if they're both negative, but if you can, try to do that negative value first. It just makes your life a little bit easier. Okay? So when you factor this one up by grouping, now you're just looking at the GCF twice. So in that first group, what's the GCF? That's just the x. So if I factor out the x, I'm left with 2x minus 3. And now what's my GCF? 7. Very good. Factor out a positive 7, I'm left with 2x minus 3.
Whoa.
Yeah, here.
The number after 6. That was like a 7. What's wrong with it? What's wrong with 7?
I thought I wrote something wrong, and I'm like,
Yeah, I know. I was like, wait, what?
Everybody just kind of gasped. Oh my God, it's a 7.
Okay, right, well, you moved that to part of the equation.
What's the GCF of 14 and 21?
I got that, I thought you were still on the 2x minus 3.
Oh no, we moved on.
Gotta be honest.
So, are both those things in parentheses the same?
Yeah.
When these two guys wind up being the 7, you just write it the 7. Being the same, you just write it down. And you got x plus 7. Okay? Now, these skills and these things of ways of doing stuff here. Guys, don't worry about that later. Jeez Louise.
We've already done this before.
I know, but I'm trying to get you ready for the hard stuff now.
No.
Because you use the same skills when you get into higher degree polynomials.
Not fun.
No.
So, one of the things that I would want you to notice here is in this polynomial, how many terms are there?
4.
There's 4 terms, okay? X cubed minus 2x squared plus, x cubed minus 2x squared minus 9x plus 18. Since there are 4 terms here, that's usually leading me into factoring by grouping. It's kind of a big dead giveaway hint, okay? Now, even though that our polynomial is a higher degree, you still do the same basic stuff. So, for example, when I go to group these two, well, let me just rewrite here. When I go to group them, I'm going to do a minus plus in here, or a plus minus, excuse me, just to make my life easier. I'm still going to be looking for GCFs twice. So now what's the GCF of my first group?
X
squared. Very good. So I factor out the x squared, and I'm left with x minus 2. In that secondary group, I had a negative 9x plus 18. Remember what my rule was for when you had a negative for that first value? Take it out. Well, I'm going to take out the negative 9, and then what am I left with? X minus 2. Okay. Now, are both of those things that are in the parentheses the same?
Yeah.
Yep. So I write it down. We have x minus 2. And what am I left with? X squared minus 9. Am I done yet? Difference of squares. Is x squared a perfect square? Is 9 a perfect square? Is it a subtraction sign?
Yes.
Which means I can still factor. So I wind up now with x minus 2, x minus 3, and x plus 3. What's happening here is that we are winding up with more factoring if needed. It's going to get you, well, it's a third degree polynomial, right? Which means it could have up to 3 possible zeros. That's kind of the basis of how this works. It's kind of, we're going to talk about this later on. It's called the fundamental theorem of algebra, and it talks about possible zeros. Hey, Izzy.
If you were to be x squared plus 9, you can do it.
Correct. You'd be done. You'd be done. Now, unless it said that. Because if it said that, you could give me my zeros then, right?
Yeah.
You could solve it, but you couldn't factor it.
Okay.
All right? That's a great question. If it said x squared plus 9, we're done. If it said x cubed plus 27, could you go further?
Yes.
And you'll see stuff like that as well. So it's not that bad, is it?
Nah.
To be honest with you, I think you guys would be okay here. So let's start with A. We'll come back to B here in a second.
They all have.
God bless you.
They can all. They have 4 things going on.
81 x to the 4th minus 16. Now, let me give you another kind of a generic idea here. Does everybody agree that there's 2 terms?
Yeah.
Does everybody agree that it's a subtraction?
Yeah.
Does everybody also agree that it's an even exponent with no exponent after it?
Yeah.
Now, if it's an even exponent, or actually I shouldn't say exponent after it. Since it's an even exponent, could I take the square root of 4?
Yes.
So what's the square root of 81x to the 4th?
9x squared.
What's the square root of 16?
4.
Is that a subtraction symbol?
Yes.
Isn't that a difference of squares? This is a funky looking way of writing a difference of squares. The square root of 81x to the 4th is 9x squared. The square root of 16 is 4. And what do I have to do with my signs? Plus and minus. Now Izzy, which one of these should I go further with? The minus one. Everybody see that?
Yeah.
The subtraction one I can go further with. So the 9x squared, just write it down again, 9x squared plus 4. I cannot factor that any further because I wind up with an imaginary solution and I can't do that because it's just factoring. But the other one, what becomes my other two terms then?
3x minus 2.
3x plus 2.
Okay? Do you see how we're just pushing the boundary of what you guys have done in the past? Yes, ma'am.
You said that if it has like, in the last one it was 3, so it can have up to 3 possible zeros, but can have also.
Yes, it could. Yes, it could. Now, I want to be careful how I say this, but when you start to think about possible zeros, you have real and imaginary. You can have an imaginary zero. I'm thinking about it right now.
That's right.
No, it wasn't. Okay. I don't know. I have no idea. I just kind of show up for work and show people how to do math.
Alright.
If anything else happens, it's just ancillary.
4. 4x squared.
It's always your first rule, if possible.
There is a GCR.
4x
Very good. Everybody's already starting to mumble out here. I could factor out a 4x squared, right?
Yeah.
Yes.
Okay. If I factor out a 4x squared, what am I left with?
X squared. X squared. 5x squared. Plus 6.
Okay. Now, can I factor that trinomial with the exponents of 4, 2, and nothing?
No, it's at 0, right?
I can't. No. Well, okay, all right. Hope you're not wrong, but I just haven't shown you how to do that yet. Take a look at what we have here. X to the 4th, x squared, no exponent. Think about x squared, x, no exponent. Isn't that just cutting your exponents in half each time?
Yeah.
So you can do this. When your exponents are descending like that, it works.
But don't you have an X on the last one?
No, let me show you how this works. If this was just x squared and an x, I'd ask you what times what is 6 to add together get negative 5. What would it be?
1 and negative 1 and 5.
3 and
1 and 5.
3 and 2.
Six.
Oh, I was thinking that.
Oh, yeah.
So you'd have x minus 3, x minus 2, right?
Okay, what?
No, this isn't.
If this was x squared and an x, well, it's just this thing.
Oh.
That's all it is.
So you just throw a square?
That's all it is. Because if you FOIL that back out, you get x to the 4th minus 2x squared minus 3x squared plus 6. Oh, yes, thanks. I forgot to write that down. So now within each of those two terms we've created, can I factor either one of them any further? No. No. I'm done. That's a factored form of what we just wrote down. That's as far as you can go on that one. You guys, if this was set equal to 0, you guys could tell me all my possible zeros. What's my 0 for this first group? 0. What's this one?
Also,
And what would this be?
Plus minus the square root of negative 2. Oh. Okay.
Because what you're doing is you set each one of those individually equal to 0 and solving for x. Add 2, take the square root. Add 3, take the square root. Divide by 4, take the square root.
4. No, x squared plus 4. And you subtract it from 2I.
And we'll see that as we go further along here. Sir?
Oh, that's right, I was stretching.
Yes, sir.
How was it, how many?
Am I subtracting 3? Or am I adding 3? Adding 3. Whenever, when you're setting these equal to 0, in order to solve for x, you add 3. So you have x squared equals 3. Then you take the square root. And what happens when you take the square root over the equal sign? That's how it works. Okay? Now, what they were asking is if this was an x squared plus 3, then we'd have to worry about having an I in there. But we're not there yet. Okay? We'll get to that. What's the thing? Having an I? Yes.
I have 2 X's.
Ah, you actually have 4. All right. So while we're at it, let's try and do one that's a solve.
Is that a plus? Or
Yeah, I was just trying to make it so it doesn't look so pleasant. Take a minute. Solve for your zeros, please. Take a minute and see if you can solve for your zeros. Move stuff over. We have 2x to the 5th minus 14x cubed plus 24x equals 0. First rule is to go ahead and take care of your GCF. 2x. We're left with x to the 4th minus 7x squared plus 12 is 0. So what times what's positive 12, but you add together to get negative 7? Negative 3, negative 4. So we have 2x, x squared minus 4, plus you, x squared minus 3 equals 0. Which means I can go further. 2x would be x plus 2, x minus 2, x squared minus 3. Now, you guys probably didn't do that step. In all honesty, you don't need to because of that. If it was just a factor completely, you have to factor completely. You can't leave it as x squared minus 4 because you can go further. But since this is an equal 0, it's not the end all be all. So what are your possible zeros then? Well, 0, plus or minus 2, and plus or minus the square root of 3. And take a look. You have a 5th degree polynomial. How many possible zeros do you wind up with?
5.
What direction is this going?
Up. Wait, it's 5 down.
Yeah. Did I show you guys the rerun dance?
No.
I'll show you later.
How about now?
Now I'm busy.
What? You can't just say that and then not show it.
well, he's going to show us
It's like
later.
a little carrot in front. You know, if you put away all of your dishes, I'll give you a piece of chocolate. I just made that up.
Yeah, I don't think I
So do we get chocolate?
No, because I'm not allowed to have treats. And you can't have treats in school because the world is obese. So children go to kindergarten dressed in Halloween costumes, can't have a Halloween party.
I don't want mom about
I'm not bitter.
I should have mom how you do it.
A lot of them can't.
See, I'm out of here. Children's.
Like legit,
People should be allowed to
I ran.
I'm joking.
I ran.
We want to do
That is, you know what? It's absolutely fine to do that. I've never done it that way, but that's fine if you want to go that route. There's no problem with that. Huh? I never thought to do it that way.
I was just thinking that.
Yeah, she just regrouped them differently because remember, order doesn't matter when you're adding, and that's a pretty cool idea.
Yeah, I like my way.
You make your zeros backwards.
I noticed that you make yours.
What's in there, zero?
I know, you see what I'm saying? It's like you're left-handed.
At least none of us are starting.
Alright, so
Yeah.
we don't need to just put
No, he
zeros
starts
down.
all of his letters with
Put them
That's
down.
what
don't need to show all the
makes your
words.
handwriting so bad, Sebastian.
Excelente! Que bueno! Hey! Hi!
She does it after.
No, that was cool. Did you learn that trick for putting them in that order like that somewhere else?
Yeah.
I
Who
did.
showed you guys that?
Miss Johnson.
No, that's cool. I never would have thought to do it that way.
I don't know what you.
Me, I just would have moved them over and taken out the x squared first. And
That's
then,
what I did.
and that's fine. Because what this is doing here, when you have these polynomials, and that's pretty cool. I never would have done it that way, but it's right. All you're doing is just moving the orders around. And remember, the commutative property of math says that order doesn't matter when you're adding, or order doesn't matter when you're multiplying. So that works perfectly fine. So nice work.
Is that it?
I might have.
We have to do this one.
Let's
Wait,
not
what?
do that one.
No, I'll give you some homework.
Oh, 684, 88.
Oh, shoot. I did my notes. On my
Does that have a hundred?
I think that's the ones I wanted. Yeah. Evens.
Oh, even. I did not see the evens. I was like,
All right.
That's still a lot.
It's still section 6-4.
Oh, that's a lot.
It's 13. See how fast these are? Yes, ma'am. Yeah, that's what I'm saying. Go ahead. Most of you guys might have still have room on your paper from yesterday. Just add to it.
yeah, I'm not.
Please tell me 88 is not a word problem.
It is, and you'll be able to figure it out because you have intelligence. Yeah.